the topics, what topics we are going to cover in this program, the training program. And then we'll start with the case study introduction. So once we complete our course, we have a case study which you have to be implemented so that you can get more exposure on the real-time implementation of the Teradata utilities and tools. Yeah, so I will give a just brief introduction what we are going to achieve by the end of this course. Okay, what is the real-time case study, what we implement, and what the exposure we are going to get. Okay. And then I'll tell you what are the timings and plan of execution for this program in November. Okay. And then I am open the lines for all your questions. You can clarify your questions. Okay. So let me start with why we want to use the Teradata. Basically, for any business, if it is a banking business or if it is a telecommunication business, whatever business we do, we have so many customers who do transactions, and for each and every transaction we have to have a sophisticated RDBMS to store the data in order to generate different reports. Okay, there could be transactional reports you may generate, there could be analytical reports you may generate. For basically, in order to generate those reports, we have to store the data somewhere. Okay, so nowadays, each industry would use an RDBMS to store the data. Okay, so they may use the traditional RDBMSs like Oracle, SQL Server, DB2, Sybase, everything, or they may use SAP datasets, SAS datasets, the ERPs they may use to capture the data and to maintain their applications. Finally, whatever RDBMS, whatever ERPs they use, finally they have to maintain in a data warehouse, a repository of the data with the historical information, okay, which can give you the analytical power of the data. That is where you can analyze the data and can take the business critical decisions. Okay, so at the data warehouse, so again, data warehouse is nothing but the repository of the data, okay, where we will extract data from different sources and would maintain in the data warehouse application. Okay, so there we have to have very much sophisticated RDBMS. So there also, if you use a traditional RDBMS, you may hit a performance problem very soon. Okay, we'll see that here. Okay. So let's suppose at the OLTP also, generally at OLTP we use the normal traditional RDBMS. So when we have 1000 records, let's suppose the disk which is capable of storing lots of data, but right now let's suppose we have some 1000 records and there is a processor which is associated this memory and it has up 2.5 gigahertz power and it takes 1 second to process the data. Okay. And data is not stable, right? It keeps on growing as the business grows and as the customers do the transactions. So the business data would also grow because of the transactions what the customers do. So when the data increases, can I process the same data with the same time? Because the processor capacity is same, but the data is growing, so automatically the number of seconds required to process the data would also grow in a proportional way. Okay. So after 1 month or 2 months, if data grows again, then again the time required to process the data would also increase like this. Okay. And who use these transactional systems? Yeah, these transaction systems are used by the customers and the employees of the company who serve the direct customers. Right? So when I'm using the transaction system and when I'm hitting the problem, okay, so I used to do a single operation in 1 second earlier, but after 3 months or 4 months I have to wait for 100 seconds to achieve the same operation. Does it mean that I hit with a performance problem of the system? Right? So in order to make customer satisfied, we have to use a definite technique so that they won't hit the performance problem. Okay. For example, this is an online banking portal. Okay. I used to do a fund transfer transaction here within 2 seconds or 3 seconds earlier when the bank was new, and when I was also new to the bank, I used to complete my fund transfer transaction within 2 seconds. But now, as bank has more and more customers and more data, the same fund transfer operation is taking 100 seconds. It's fine, maybe 100 seconds or 1.5 minutes I may wait, but after 2 years, what could happen? I may have to wait for some minutes. Okay, maybe after 5 years, I may have to wait for almost 1 hour for the same operation. Can I stay with the bank as a customer? Okay, so there is a chance of losing customers for any organization if they hit with the performance problems. Okay, but at the transaction systems, there is a solution for them. There is an easy solution. What they can do at the transaction systems, okay, they may archive the old data, and at any particular time they will ensure there is a sufficient amount of data which would be processed very faster by the system. Okay. So when the data grows, they will identify there may be a problem. They may set a threshold, whether maybe in the size of the data or the age of the data. They will set a threshold that the system should have only the recent 6 months of data at any particular point of time. The recent 6 months data is only to be maintained in the transaction system. The older data should be archived and should be copied into another system called analytical system. Yeah, this is nothing but the data warehouse or decision support systems, whatever we may call. Okay, so the transaction systems cannot hold the huge data because of the performance issue. So they have a technique of archiving the older data and keep it in the analytical systems, the historical systems, the data warehouse, the decision support systems, okay, whatsoever you call the analytical systems. Okay, the older data will be archived from the transaction systems to the analytical systems. Okay, so here the customers are happy because at any particular time I'm ensuring there are only limited number of records so that the transactions would happen within expected timings. So here my customers and employees are happy because they are getting their services within estimated timestamps. Okay, so here you can use any of the RDBMS which can give you the normal performance because we are ensuring there is limited data here. But how about here? When I started archiving the old data here and keeping it in the analytical systems, it is also a system, but it may be of some high sophisticated system which has huge memory and huge processor capacity, like 4 GHz here when compared to 2.5 GHz. Yeah, and it has huge disk memory also because it is an archival and it is the historical systems. So here the 10,000 records are processed within 1 second with the capacity of this 4 GHz. But every day, every transaction system sends their archival data to here. So this data also grows. So when this data grows, again, it is fixed. It may be huge, but it is fixed. We cannot improve or increase the processor capability at any time. Right? You may increase the memory, but there is nothing you can increase at the processor level. You may increase the hard disk, you may increase the RAM memory, but you cannot increase the processor capacity. Right? So when you have huge data which is keep on growing, then automatically the time required to process the data would also increase. Okay, so when the data grows like this after 1 month, then again the time required to process the data would also increase in the same proportions. And who uses these analytical systems? The executive users of the organization, the CEOs, the CFOs, CTOs, they are all the chief executive officers. They are the executive level employees who are responsible to take critical decisions based on the past analytics, use these analytical systems for their business critical decisions. So here they used to generate their analytic reports within 10 seconds or 1 second, but now after 3 months and 4 months, you are asking them to wait for 100 seconds for the same report they used to generate within 10 seconds. Okay, but even after 1 year, they have to wait for 1000 seconds. So is it possible to ask them, these executive users, to wait for a simple report which used to be generated in 10 seconds, and now they have to wait for 1000 seconds? Can we ask for it? Because the time of executive users is very much precious. So we should not waste their time in unnecessary things of waiting for the reports. Okay, so they are doing well business, they are getting amounts, they have sufficient funds, so they ask technology to come up with a solution where they should not get into the performance problems. Because if any critical decision is wrong or late, then they may have to pay so much of penalty in terms of profits, in terms of growth of the business. Right? Suppose we have so many competitive banks and we are trying to introduce a product and we want to see, okay, how to introduce the product and what was the past experience when we launched the previous products. Okay, I asked to generate a report, okay, what happened or how many new customers we were able to get when we launched a product last year. Okay, so I asked them to wait for these many number of seconds or maybe some hours, and within those minutes or seconds or hours, if any other company has taken a decision and they have announced it, then we cannot announce the same plan. Right? So if they get benefits of that plan and we are losing the business due to the delay in our decision making, because we cannot copy the same plan again, right? So all competitors would continuously try to achieve the campaigns by introducing new products, new discounts, everything. So if we delay introducing the new plan, then the other competitor would get the benefit out of it and we'll lose the growth opportunities. That is how it is very much important for them to have performance at the analytics also. So they have funds, but there is no technology which can give them the sufficient performance which is required for their analytics. So when this problem statement was there, materialized, TERADATA has come up with a solution. Okay, what is the solution they have come up with? Okay, so this is the existing system where a processor is associated with the disk memory, and whenever the data grows, the number of seconds to process the data would also grows, where we want to stop here. Right? So TERADATA has come up with a solution called the PDE, this parallel database extension. They have invented a software by installing which on their TERADATA machine the hardware processors start behaving as multiple processors. There is a single hardware processor, but by installing their invented software PDE, the software makes the hardware processor to work as multiple processors. Okay, these are the software components of the processors, but can do all the actions that a hardware processor can do with the same capability. Okay, so they invented such a software called parallel database extension, by installing which on their machines the processors start behaving as multiple software processor components, which are called as virtual processors, because they are not hardware components but the software components, but can do the same actions that a hardware processor can do. So they are called as virtual processors. A similar way, the memory here, the memory, the disk, hard disk would also start behaving as multiple software components of the disks. So they are also called as virtual disks. And there would be an association in between the virtual processor and virtual disk. There is a dedicated communication plan across each virtual disk and virtual processor pair. Okay. Each virtual processor can run independently on its portion of virtual disk. Okay. There is no dependency in between these two processors or these three processors because they have their own virtual disk associated with it. Okay. And coming to the data is also distributed across all the virtual disks almost evenly. Okay, so there are techniques how we can get the data distributed across all the available virtual disks evenly. Okay. So with that indexing and data distribution techniques, they get the data which is also distributed across all the available virtual disks almost evenly. So these 1000 records here, okay, it could be distributed like this. In first virtual disk 350 records, in the second virtual disk 300, and the third virtual disk 350 records. Okay, and the corresponding virtual processors would take the relative processing time to process their own portion of 350 records. Okay, so this virtual processor has the same capabilities of the hardware processor, would take proportionally 3.5 seconds to process it, isn't it? Because here 1000 records are processed within 10 seconds. Okay, here for running the example, we'll consider 1000 records would take 10 seconds to be processed by this machine, and this virtual processor also has the same capability and it has only 350 records to be processed, so it would take 3.5 seconds. Similarly, the second virtual disk which got 300 records, it has 3 minutes to process the 300 records, and the third one would also have 350 records, so it would take 3.5 seconds to process their corresponding portion of the data. Okay. And please note, each virtual processor is running parallelly on its portion of the data. There is no dependency across the processors, so they are running parallelly and each one would work individually on its portion of data. So how much time it takes to process this 1000 records, this architecture of TERADATA? It is the maximum time taken to process the data by the virtual processors. So what is the maximum of 3.5, 3 and 3.5? It is 3.5 seconds. Okay. So where with the traditional system I used to process the data with 10 seconds, and here with the TERADATA system the same 1000 records are processed with 3.5 seconds. Okay, so how much optimization or how much performance I got with the TERADATA system? Can I say almost 60%? It could be 65%. So I'm taking 60% of performance I got with this TERADATA machine. Okay. With this configuration, I may be happy for 1 year, let's suppose. Okay. Without performance, I am able to process my data and I am able to generate my reports within time for 1 year worth of data. Okay. But after 1 year, I may hit a problem. But here, if I have the TERADATA system with this architecture, how many years I can be happy with the system of 60% of high performance? Okay, I can be happy for at least 4 to 5 years. So here it is one year. So here I may be happy for almost 5 years, let's take. Okay, because it is 60% high performance. Okay. And after 5 years, here also you may hit the performance issue, isn't it? Because the data is keep on increasing, the business grows, the customer base grows, the transaction grows, the data also grows. So after 5 years, I may hit a performance issue with my TERADATA system. So what is the solution here? I can purchase one more TERADATA license and I can plug in with the existing TERADATA node. In terms of processor, in terms of memory, I will plug in the new system with the existing system. I have purchased a new TERADATA node and plugged in with the existing node. And when I upgraded it, I will do a restart with the data so that the whole data is distributed across all the available virtual disks now again. Yeah, so the 1000 records has to be distributed across 6 virtual disks now, because in my configuration now I have 6 virtual disks and 6 virtual processors. So the data distribution mechanism would ensure we will have the data distributed across all the virtual disks almost evenly. It may not be 100% always. Okay, I'm showing some skewness because of the real-time scenarios. Okay, there may be some skewness, so it could distributed across all the virtual disks almost evenly. So now, what is the time taken to process? 150 seconds. Relatively, it would be 1.5 seconds, and here it would be 2 seconds. It would be 1.5 seconds, and again 150 records, so 1.5 seconds, 200, 2 seconds, 150 records, 1.5 seconds. So now processing, for processing 1000 records, what is the time taken by this virtual machine architecture of the Teradata? It is again 2 seconds. This is the maximum, right? This is the maximum. So it requires 2 seconds to process the 1000 records now. So earlier with 3 virtual disks it was 3.5 seconds, but by upgrading the system I got 2 seconds. So how much performance I got here? Almost 40%, can I say? 3.5 to 2 seconds, so it is almost 40% of improvement. So I can be happy up to 4 more years, or maybe 2.5 years, because it is 50% relatively. So I may be happy for 2.5 years more. Okay. So I'm not hitting the performance problem because we have the characteristic called scalability. Okay. So within the single system we have seen the characteristic of parallelism, where each processor parallelly runs on their portion of the virtual disks. Okay. Once we hit the problem, we may upgrade the system so that it will improve the performance. The property of adding new systems to the existing system is called as the scalability. Okay. With this help of parallelism and scalability, we always be happy with the systems. Yeah, this is how Teradata is evolved in the industry of data warehousing, because there is the problem of growth of data and where you may hit the performance issues. So Teradata has come up with the solution with its PDE and the scalable mechanisms, where you can scale the systems maybe up to 4096 as per the current configurations. So you can use 4096 nodes, and each node is capable of processing 85 terabytes. Yeah, so by combinedly it would be almost 200 petabytes it can process. So there is no industry now which has 200 petabyte, but it has the capability to process 200 petabytes of data. With the 4096 of nodes, each node is capable of processing 85 terabytes. Yeah, this is the capability of Teradata, and which gives a solution in order to not to get performance issues. Yeah, okay, I'm sure you can ask questions. Okay, let me unmute.
Unmuted.
See.
Yeah, basically, you can hear me, right?
Yep. Right.
Basically, you told like
Muted.
the PD is a software which Teradata recently, or whenever it got, they come up with the software. But all these processors, virtual processors, and virtual disk, this is the hardware component of Teradata.
No, these are also software components.
Okay.
That's where it is called as virtual.
Okay, it's part of the software itself. Now you said like, okay, the data will be evenly distributed across multiple virtual disks. So that is related to any kind of indexing, or else it will automatically take care of the distribution of the data?
No, the data distribution technique is index. Okay, so we have primary index, secondary index, all other indexes, where with the help of indexes, we can get the data distributed across all the virtual disks. So basically, it is a primary index which enables to get the data distributed across the virtual disks. Okay, so we'll see what is the indexing and how it helps
Unmuted.
to distribute the rows, okay, in the indexing concepts.
Okay, let's say if we don't have a primary index defined, that means the data won't be evenly distributed.
Yep. If the primary index
Muted.
then that data may not be distributed across virtual disk. So there are some baseline thumb rules how we have to choose the primary index for the table so that we will get almost even distribution across the virtual disks.
Okay. Let's say for example, if I haven't if I haven't created the primary index, instead of primary index, let's say I created a secondary index, then also it will eventually evenly distribute the data?
No, secondary index is not responsible for the data distribution. The secondary index is for optimizing the secondary pass. It is advanced technique of optimizing the data, but primary index is the basic to distribute the data across the virtual disk. So without primary index, you cannot distribute the data properly. But there are some techniques, again in TERADATA 13 with no PI table, where it will randomly generate the numbers. Okay, but for now, till TERADATA 12, we used to say primary index is mandatory for the table. And this primary index only would decide how to distribute the data across the virtual disks.
Okay, okay, that's fine. Like we will go into the detail like whenever we start. But the demo session, I'm okay.
Yeah. Any other questions, anyone? In the process, what we have seen so far?
So I have a question. How is this different from partitioning with other database systems provide?
Partitioning is to optimize the retrieval processes, right? So when you use a particular date range in your SQLs, suppose select star from this employee table where the joining date in between so and so, then you will get an optimization of partition. So when you partition the table based on the joining dates. Okay, but if you don't use anything and if you use only your primary index to retrieve the data, then primary index, the partition primary index cannot give you the optimization. Okay, so here it won't partition the data, it just distributes the data based on the primary index. Okay, in TERADATA, as it is also in RDBMS, it also supports the partition primary index. So that is a different concept to optimize this range-based queries. In any RDBMS, I hope the partition primary index is to improve the range-based SQLs, right? So that is also supported here, but it doesn't depend on the data distributions.
Hi Manohar, this is Srikanth.
Yeah,
Manohar, you mentioned there about Teradata we can use 4096 nodes by nodes. So do you mean processor?
No, here this is a node. When I say node, this is called as a node. So like this, get current configuration as we have the processor. Now Intel has the processor with the highest configuration of i7, if I am not right, right? So we have Pentium 3, we have seen Pentium 3, Pentium 4, we have seen i3, i5, now i7. Yes, in a similar way, TERADATA has also evolved its processors. Okay, they call it as 5000, 5500, 5500X, 5500Z. Okay, these are the configurations what they release with their capabilities. Okay, with the highest maximum configuration, they can combine up to 4096 nodes, and where each high configured node can capable of 85 terabytes of information to be processed.
Is node another word for amps?
No, it is this, the node. Okay, as maybe most of you may not be knowing amps, so it is, right now I'm calling it as virtual processor. So node is the combination of the hardware processors, the software processors, the software disks, hardware disks, and whatever communication channels required to make communication happen between these virtual components. Everything is called as a node. It is not an amp. Yeah, that is the node. Okay, in my first session, I will give you the architecture part. Okay, so there you will get more understanding what these virtual processors are called, okay, what these virtual disks do, what is the responsibility of each virtual processor and how the communication happens. So how the communication happens across different virtual components and how communication happens across different nodes, everything I would explain in my first session, the Teradata architecture. This is to understand the features of Teradata, how the parallelism would help us to process the data within less number of time, and how we can scale the units so that we never hit the performance issue. Even it is a data warehouse where we are maintaining some petabytes of data, still you are not going to hit the performance issues. So these are the capabilities I would like to brief you in this demo session.
Unmuted.
So clear about the features, the characteristics and features of the Teradata system. Okay. If you don't have any other questions, I will walk through the curriculum, what we are going to cover.
Hello.
For the